let's get a look at that second question that came up in Lab 3, questions at the last page, second page, second question. And they ask us now to get out of back into our lab frame, not the center mass frame, but say something about the relationships between the vectors, VT and VP. All right, let me remind you what all these objects are. So after our collision, we have VT and VP, right? These are the two velocities of the particle after the collision. And what I'm going to do now is argue for the case that's suggested to us. Just think about the case of equal masses. So I want to get a relationship that might tell us what the geometrical relationship between those two vectors is. So what I claim first is I can write down, it's always good to write down momentum conservations here. So what's the momentum in the lab frame? Well, the lab frame is where the target is sitting still at first, in which case the only momentum you have is the incoming particle, projectile's momentum, we call that VI. And that is the outgoing momentum. First the part due to the target, and then the part due to the projectile. All right, so that simplifies and tells me that VI is just VT plus VP. Okay, so it means that there's some kind of triangle in there. So let me draw a triangle. So here it is. Vector addition of VT plus VP gives me VI. Okay. Now, there's another relationship, and that's because this is a case of just having nothing but kinetic energy conservation. So the incoming energy is VI, 1/2 m VI squared. The outgoing energy, kinetic energy, and that's the only energy there is after the collision, is going to be the target bouncing around with this kinetic energy, and then the projectile. Okay, and I can simplify that one too. VI squared is equal to VT squared plus VP squared. Well, that triangle isn't quite perfect because according to Mr. Pythagoras, if you have this going on, I really should have had a right triangle. So this would have been VT here, VP over here. In order to have this relationship where these do this, which is what a right triangle does, I should have drawn it like that. So that's your official triangle. That angle between those two, it's got to be a right triangle. And that's what happens in the lab frame for equal masses.